Welcome to the next lecture of Software Design and Modelling. And today's lecture is going to go through a few important patterns and talk about their connections. So these are the three that I'm going to focus on. There's nothing terribly special about these other than that they make quite good illustrations of some general points about patterns. I'm not spending a lot of lecture time on specific patterns this year, or indeed the last couple of years, partly because there are a lot of good sources of information about them elsewhere. So at the end of the slides there's a list of specific patterns that I do expect you to understand in detail, including these and some others. And of course you may well like to read about ones which are not on that list. So I want you to understand how these patterns work and how to use them individually. But in a way it's even more important to understand how they're related and how they contribute to good object-oriented design. So I said when we talked about patterns in general that I thought that perhaps using the understanding of patterns as kind of exercise for your design muscles was maybe the best thing about patterns, and I hope to illustrate that as we talk about these patterns today. So let's jump straight in with what is perhaps the simplest pattern of all, namely Singleton. So, in object-oriented systems, it often happens that a class has and should have only one object. Perhaps it controls some important piece of data that has to be held consistently. You mustn't have two different versions of that datum. Or maybe the role of the object is to manage a connection to some external system, and everything will go wrong if your system has more than one conversation at the same time with your external system. So these are the kinds of situations in which you might want to be able to ensure and easily check that your system could never have more than one copy of more than one object of a given class. So Singleton is the pattern that ensures this, and a key element of the pattern is that we make the constructor private, and that allows us to control how objects are created. So recall that when you have a private method in Java or related object-oriented language, what that means is that the method can be invoked from anywhere within the code of this class, but not from anywhere else, including not from subclasses of this class. So here's the class diagram of Singleton, and it's important here that you understand the UML notation that is underlining the specification of the attribute instance there and the method getInstance, because this is telling us that these are static attributes and operations. In other words, when you want to access an attribute or send a message corresponding to the method, you aren't doing so for one specific object, you are doing so for the class as a whole. There is only one instance of these things. And of course that's essential, because otherwise you wouldn't be able to get started. The constructor is private. You can't create an instance of this Singleton in the first place. Except of course that obviously what's going to happen is that the getInstance method is going to create an object of the Singleton. So what's going to happen here is that we're going to start off with that static attribute of the class instance having the null value. You see we've got the default value null there. And when a client calls the static getInstance method, that's going to return an instance of Singleton. So at that point there will be an instance of Singleton. Probably what's happening is that inside the getInstance method code, the private constructor of the Singleton class is being created. So when you as a client ask the Singleton class to getInstance, and if it so happens that no other client has asked this class to getInstance previously in this run of the system, then a new Singleton object will be created, and then you will be returned a reference to it, and you'll carry on quite happily using it. If on the other hand you are the second or the 17th client to invoke the getInstance method to send a getInstance message to the class, then what will happen is that the code of the getInstance method will simply return the existing value of that private instance Singleton. So you'll get a reference to the same Singleton object, which is the value of that static attribute instance. And the effect is that whether you're asking first or later, you don't need to know whether you're the first one to ask or not. As far as you're concerned, this just gives you some instance of Singleton. And as far as what goes on inside the class happens, creation of a Singleton object will happen when it needs to happen. So this gives us a number of advantages. One thing is already implicit in what I said about it there. We've got lazy instantiation, so the instance need not actually be created unless or until it is needed. And maybe on some runs of your system it happens that you never need to create a Singleton object, in which case we've saved the resources that would be needed to do that. A drawback is that we have essentially introduced global state. So the Singleton object is now an object which can contain state, which can be referenced by things all over the system, by anything which has access to the Singleton class itself. And so people sometimes criticize Singleton as being just a way to have global variables in your system. And we all know, I hope, that global variables are generally considered to be a bad idea. Why? Because they're introducing a lot of coupling in the system. It will have implications such as that if you, change the type of the global variable or something, now everything that references that global variable has to change its code, and similar things will happen here. There are also all sorts of interesting issues that arise in multi-threaded applications about exactly how this is going to happen, and I think you can read about that on the Wikipedia page in excruciating detail. Maybe you need to go to the talk page of the Wikipedia page, I forget exactly. Singleton is often useful in conjunction with other patterns, and we'll see some of that coming up. And so the bottom line is, Singleton's very useful from time to time, but it's quite easy to overuse it. Okay, so use it sparingly. So an exercise is to read the Wikipedia article on Singleton, which includes lots of implementations and discussions of their pros and cons, and also some discussion of the use and abuse of Singleton. And you also might find it interesting to read the talk page of the Wikipedia article, as I have said before. So here is a bit of a strand of discussion which is going to take us into the next pattern. Here's an odd thing about object-oriented programming in the languages which have become popular, which sometimes we don't even notice because it's kind of become how we do things. Typically what happens is that the clients of some class name control the instantiation of objects of that class directly. So the client's code will contain lines like new class name. Okay. So this has two effects. One is that it's the clients that have the responsibility for deciding whether, when and how to create objects of the class, not the class itself, and so that means that we may then have that responsibility widely distributed through the system, especially if a given class has many different clients. And of course controlling that is part of what we were trying to do with Singleton. The other one, slightly more subtly perhaps, is that new is not polymorphic. You might say, what? Huh? Of course new is not polymorphic. But this is kind of important. So it takes a specific class name and it creates an object of exactly that class. Okay. So if you have a client which is almost all completely ambivalent about which subclass of a class it should be handed, perhaps you've got a family of subclasses of a given class which all implement the same interface or implement the same API in slightly different ways. It may well be that a client only wants to use that API and doesn't really care what specific object it is that is implementing that. Perhaps that's really a thing that ought to be decided as part of kind of configuration of the system or even at runtime. But the client will still have this one special line in it where it goes new my specific class name. Okay. And that can be a problem because it gives you a dependency of the client on the specific subclass that it's actually going to create an object of, where maybe that dependency doesn't feel as though it needs to be there at all. And by the way, this is what leads us on to dependency injection. And you will probably have come across that in many different frameworks if you get into sort of software engineering of object-oriented systems. And precisely the reason why dependency injection frameworks and the like have become so popular is this problem. Okay, but there's a sense in which they're a bit of a sledgehammer to crack a nut sometimes. So we're just going to see how you can improve the situation within the context of plain ordinary Java programs. Okay, so it's not so much that new is considered harmful, as that new is considered sometimes harmful if misplaced. By the way, I hope you know what this X considered harmful is a reference to. If not, go and Google go to considered harmful and read up on that. So the use of new in Java systems and the like is sometimes a problem. Well, what can we do instead? We've already seen one thing you can do instead, because the Singleton pattern can be seen as a way to give an alternative to explicit control of the creation of objects in clients, because as we saw, the point was that a client can get an instance of the Singleton class whenever it wants, but it's the Singleton class itself that has the responsibility for actually creating the instance. Now the funny thing is, although Singleton is named for the fact that we are supposed to be using it in a case where we're supposed to have only one object of the Singleton class, the actual mechanism that the Singleton class incorporates doesn't have any specific issue with there being just one, if you think about it. We could perfectly well have the class that has a private constructor and a method to return an instance on demand do something else. Perhaps, for example, it needs to manage a small number of instances of itself because each of them is going to manage some connection to an external system where, I don't know, it's fine to have up to 5 connections to the external system, but if we had 50 we'd run into performance problems, for example. And in that case, the class could look at how many it's already got, and it could create a new one if it's got room for one more, and otherwise it could reuse one of the old ones, perhaps. In the extreme case, as far as the client is concerned, it might be the case that the Singleton class is returning it a new instance of the Singleton class every single time that get instance is invoked. The client doesn't know and shouldn't care. It would be pretty weird to do that and still claim to be using the Singleton pattern, of course, so don't do that. But we're starting to see that these are the kinds of mechanisms that we can use. It doesn't, however, give us a way to address the second point about not wanting to know exactly which subclass the object that we're going to use comes from, or rather wanting to localize the knowledge of which subclass an object is going to come from. Why? Because you might start to think, well, we could have different subclasses of the Singleton class and then the get instance could return the appropriate one. We can't do that for the very, very boring reason that you can't subclass a class that has a private constructor, a private default constructor anyway. So there are kind of ways around this, but let's move away from thinking about this in terms of Singleton because that's just a bit confusing. So we're going to move on now to factory method and start to think about these things. So the times when you want to use factory method are the times when you have a common problem we've already begun to think about. You have a class and it needs to own an object and it needs to use the services of the object, and you have a pretty good idea of what the API of the object is as far as your code is concerned. So maybe we're talking about invoking the methods that form a product interface. Okay, but at the moment, your code has a line in which it creates a specific object of class concrete product, let's say, which is a subclass of class product. And perhaps because you think that's going to change quite often, you don't really like the idea of the fact that every time that changes, you're going to have to open up the file that contains the code of your class and change this line, and maybe then invoke the need to go through a complicated quality assurance process to check that you haven't changed anything else or to verify that things still work like that. Or maybe you it just doesn't seem neat. Okay, you've got a whole class that's written in terms of product, and this one line that refers to concrete product for what doesn't seem like a very good reason. It seems as though it's not really your class that should have responsibility for deciding which concrete product to create an instance of. So you might start to think, couldn't we get something else to be responsible for that choice of which concrete product we're actually going to get an instance of, so that our potentially very complicated class, which logically only depends on things that are true of all products, could also, statically, visibly, only depend on the base class product itself. So you'd like instead to have your code saying, kind of, when it wants a product, you'd like it to be able to say, give me an appropriate product, without that code concerning itself with exactly which product object is returned, or indeed how it's created. So factory method is a pattern that lets us do that. Now, before I go any further, I'm going to say that the word factory in pattern land causes a lot of confusion, because there are several different patterns and idioms which use the word factory, and people don't always agree about exactly what they mean by their names. And so in fact in this area we lose some of the advantages that I advertised for patterns earlier on, which is to say that you could use the names as shorthand in design discussions and rely on everybody knowing what you mean. Factory is a case where you may well have to explain what you're actually talking about in this specific case. And in fact, that very old Stack Overflow question, whose URL is at the bottom because I wanted to credit the diagram because I nicked it from there, is quite an interesting discussion with a number of different viewpoints expressed about what exactly it means to be an instance of the factory method pattern. So you might like to follow that up and read it. Okay, I'm just going to try not to trip over myself too much in my use of terminology, but I apologise if I do. So let's look at this diagram. The idea here is that the abstract creator class here is the client we've been talking about. This is the your class, the one that currently has only one line in it which refers to concrete product when you create it, and where you'd like to get rid of that line so that your class, your creator class, could be written entirely in terms of the more general class product and not contain any dependencies on any particular concrete product class. Okay, so think of creator as your complicated client class. Now, an operation here is just standing for something that your class is doing, in the course of which it's going to need to get hold of a product object. It's going to need a product object created. Now the idea of the factory method class is that instead of the code of an operation writing new concrete product, it's instead going to write this dot factory method. Okay, and the idea is that factory method, which in this case is shown as abstract, is going to somehow or other create a product object, and then the type that it will have in the code of an operation will be product, and that's all we will ever use about it. We don't have any dependency on concrete product. However, in fact, the factory method is not implemented in the creator class itself. It is implemented in a subclass, concrete creator, whose only purpose is to override the factory method and give it a concrete implementation which will actually be responsible for creating an instance of the appropriate product. So probably this factory method implementation is only going to contain the one line. It's going to say return new concrete product. But because its return type is product, that's fine, and it doesn't introduce a dependency on concrete product in its base class. Okay? Hopefully that you can get your head around that. Now you might argue about whether that's really improved matters. There's a sense in which creator still depends on concrete product, in that it still needs there to be a concrete product. It needs to have a subclass which depends on concrete product. But what we've done is we've kind of separated concerns. So we've now got one rather small simple class which depends on concrete product and is very easy to verify. If we wanted to change to using a different concrete product, we wouldn't need to change the creator class at all. We would only need to change the concrete creator class and then that would be quite easy to check that we'd done it correctly. You might want to argue, well, what if the different concrete product won't behave correctly in the creator's context? And if you are inclined to say that, I'm going to refer you back to the Liskov substitution principle, and then you can argue to yourself about whether that's going to save us or not here. That's actually quite an interesting question. You could post on Piazza about it if you feel so inclined. Okay, so factory method here is a factory method, and this is, at least in one reputable body of understanding in software design, the class diagram for the factory method pattern. Okay. Yeah, so that's what I'm saying in the top paragraph here. However, there are some cases in which you get some of the advantages of factory method in a case where we can allow a product, if you like, to be its own factory. And sometimes people include that kind of thing in their understanding of what factory method is. Other sources, and I think this is probably a better idea really, pick a different name for what we're going to look at next, such as static factory method, and then they get irate when people lump them together for fairly good reasons actually. But let me not labour that too much. Let's go on and look at static factories. Okay, so this is a static factory method example, okay, and it's probably not really an instance of the factory method pattern, okay. But it involves the word factory and is useful to control instantiation of objects, and so it's useful to discuss it at the same time. Okay, so this is a classic example. We've got a class point, and hopefully you remember from school mathematics that there are several different ways to specify a point in a 2D plane here for the sake of argument. The commonest way is to use Cartesian coordinates and give x and y coordinates for your point, and that's the way that this point class is implemented at present. It has private attributes x and y, and it has a constructor which takes values for x and y and assigns those values to its private attributes to store the x and y values of this point inside. The interesting thing about this point class is that instead of simply having a public constructor that does that and nothing else, it has two different ways to construct point objects, both of which are static factory methods. By the way, also, of course, in order to be useful, this class ought to have some other methods to actually do some stuff with points. You can imagine that to be elided with a ... We've got two different static factory methods here, one of which creates a point out of the perfectly ordinary Cartesian coordinates, and all that does is give you a level of indirection to the use of the constructor. Okay, it's going to take the x and y and it's going to pass them to the constructor, creating a new point using the constructor. And the level of indirection allows us to allow the constructor to be private. Okay, but the interesting thing is we've also got another static factory method here, which creates a point from two different kinds of floats, one of which is going to be the radius and one of which is going to be the angle for the point represented in polar coordinates. And so then what this method will have to do is first of all to calculate the x and y Cartesian values using the appropriate trigonometry. It's going to go like r sine theta, r cos theta, right, something like that. And then having calculated the x and y, then it's going to invoke the constructor to create a point with the appropriate x and y and return it to the caller. And the effect is that clients of this point class can create points using whichever kind of coordinates is most convenient to them. And then they can carry on using the other methods, which I'm not showing on this slide, of the point class exactly the same way. Okay, so this is quite nice. There's a question, by the way, about whether that constructor should be private or not. Okay, the advantage of having it private is that it means we get control over creation of points, but you might want to say that's not buying us anything in this case, because we do have a public method which does exactly the same thing as the constructor would do, and so you might want to argue that we should have a public constructor and also this extra static factory method for creating points in the unusual way. Or you might want to say there's a certain amount of pleasing symmetry in having static factory methods for both of the two ways of creating a point, both with Cartesian points and with polar coordinates. And indeed, you might go a step further and say, if it is possible to create a point in both ways using both Cartesian and polar coordinates, then maybe it's a bad idea to privilege one of those as being what you do if you use the default public constructor, and maybe it's actually clearer to say we'll have a private constructor and then you will have to explicitly choose which kinds of coordinates you're using. And that's the kind of consideration that you should get used to making, basically, and try not to get too bogged down, because you can't think about every design issue in full depth every single time you come across it. Right, okay. And as usual, notice that because we can't override static methods, we're a bit limited in what we can do with the point class. Okay, so we can't now create a subclass of point that has specialized versions of create Cartesian point and create polar point, for the simple reason that we can't override static methods. In the point example we just saw, we were using meaningful names for those static factory methods to distinguish different ways of creating an object. And more generally, that's really rather a nice thing to have. It's often quite inconvenient that you don't get to name constructors, even though you can overload them in standard Java classes, because then people have to go to the documentation to remind themselves of the difference between different constructors that are provided. You might decide that you wanted to use static factory methods simply in order to get the benefit of giving meaningful names to the different ways of creating an object. Notice, by the way, there are ways you may come across but should never imitate of trying to use constructor overloading to do stuff instead. The most hideous example I remember ever seeing was when there were two different ways of creating an object that needed an integer and a string, and we had overridden constructors, one of which took first an integer and then a string, and the other of which took first the string and then the integer. And you had to remember to put the arguments in the appropriate order for the kind of construction that you wanted for that class. Don't do that, okay? Use static factory methods instead. This clear naming, of course, is something we get both from factory method proper and from static factory methods. You get it any time you replace an invocation of new by a call to some method. Finally, for this section, what's an abstract factory? Well, an abstract factory is an object containing a collection of related factory methods, basically. And this is useful where you have a whole family of different products, each with usually a kind of parallel collection of subclasses, where you want to use a consistent collection of those subclasses. So the absolute classic case is where you have a bunch of related classes, each of which has three subclasses, one for each of the three operating systems you support, or once for each of the three different GUI toolkits you support. And so then an application that's going to work in terms of buttons and windows and scroll bars is going to want to use a Mac button, a Mac scroll bar, a Mac window, and not some unholy mixture of Mac, Windows and Linux buttons, what have you. And that's really all I'm going to say about that, but I would like you to look it up and make sure that you understand it. And in this process, try to make sure that you're not going to get confused by the different uses of factory. It's much more important to understand the design considerations and what these different things that you might do are buying you than it is to commit to one view or the other of exactly what's meant by each of these pattern names. Okay. And finally, something a bit simpler. So the Facade pattern addresses the common problem that arises often in maintenance of software systems, actually. Suppose you've got your classes roughly separated into two packages, but there are several dependencies of classes in one package on classes in the other. And you end up in a situation where the packages aren't as independent as you would like them to be. You're trying to avoid people who work with one package having to understand in detail what's inside the other, but you're not really succeeding because of these dependencies. And this is particularly embarrassing if the package which is the target of many dependencies is itself really a bit of a mess and you'd like to redesign it without having to go back to the clients the whole time and have the clients update their clients for your next stage of your redesign of the messy package. So Facade helps with this by saying what you do is you'll create a single class, a Facade class, whose job it is to present a single simple interface to package B. And so then, instead of clients going directly to classes within package B requesting their services, they all go to the Facade class, and it is the job of the Facade class to forward the request appropriately, which might just mean finding an instance of the right object to send that request onto, or it might mean putting services together in some way. So it kind of looks like this, and hopefully you'll understand that's basically just what I said. Client 1 and Client 2 in the old system on the left were having to understand something about what was in the complex subsystem and go directly to those classes, whereas on the right they are just going to the Facade class, and the Facade class is managing the request for the appropriate services from the classes inside. This gives us a useful way to control dependencies, and it hides a multitude of sins, so it lets you, at your leisure, redesign the subsystem behind the Facade, and whatever's outside doesn't need to know about it. It can, of course, incur the cost of extra method calls, but usually that's trivial, so that's not usually a thing to worry about. The Facade itself might be a Singleton. That's often a convenient way to use Singleton, but it isn't always necessary, so just watch out for that. So here's the list of patterns from the Gang of 4 book, and I have asterisked, and also coloured, but sometimes that isn't clear enough, the ones that I would like you to know for examination purposes. So that means being able to describe them in detail, and of course understanding their design pros and cons and being able to apply them in appropriate circumstances. So these are the creational patterns that have to do with how objects get created, and we've talked about 3 of those today. These are structural patterns. We talked about composite earlier on and Facade today, and decorator occurs in an exercise for you to think about. And then there's a bunch of behavioural patterns about how things interact and behave. And outside lectures you're going to look at observer, state, strategy and visitor. Secretly you kind of know template method already because it's very similar to factory method, but I'll leave you to look into that. And that's where I'll stop.